Welcome to Unit 5. In Unit 5, we'll be talking about Analytic Trig. Analytic Trig is building upon our previous knowledge of Trig because we learned a lot about graphing, we understood what radians are, we manipulated functions, and we looked at it in terms of our value theta or given in x. We're plugging in theta and getting our result. We graph that, we find key points, and we put those on a graph, and then we see the behavior. Now we want to look at it the other way. Given our output, I'm saying output in this sense, it's not always output, but given the result, I want you to now find the angle. And that is what this unit will be focusing on, finding the angle in more complex ways. In other words, find theta. And to find this, we want to look at inverse trig. So for example, with this equation that we talked briefly about, if sine theta equals 1/2, what is theta? Unfortunately, we can't, just like with variables, like if I had like 2x equals 1/2, to get x by itself, I just divide by 2 and get x equals 1/4. That does not work for sine. I can't just go divide by sine, and get, oh, like theta equals 1/2 sine. That does not work. Instead, I need to find a way to get rid of it. But if we think a bit further beyond that, all this is asking us is like, find what angle gives me sine of that angle is 1/2. And we can look at a unit circle. We've done a lot of stuff with our unit circle. And it's already circled here, which is a bit of a cheating. Let me just get rid of that. But our unit circle, we see where is sine 1/2. And on our unit circle, y equals sine of theta. So see, where is y 1/2? I see right here. I have 1/2, 1/2. So I have 5 pi over 6 and pi over 6. And this is stuff we've talked about before. And we did maybe 2 questions like this. Where theta, we look at unit circle and find out, oh, theta is pi over 6 as well as 5 pi over 6. You also mentioned this before about quadrants. A little reminder about quadrants and like their results. Since sine is related to y, it is positive in quadrants 1 and in quadrants 2. Whereas it's negative in the other 2. It's negative in quadrants 3 and quadrant 4. Because y is positive in the top quadrants and is negative in the bottom quadrants. Cosine is also positive in quadrant 1 and quadrant 4, and is negative in quadrant 2, quadrant 3. In a little bit, we'll talk about tangent, but we'll pause on this for now. You must know this table. So we're able to solve it like this, but using the unit circle every single time is not great. It's slow and it doesn't cover every single angle. Even on some of our midterms, we talked about like cosine being 1/2. If you remember that question, being greater than 1/2, less than 1/2, what are the odds? And it's not 50-50 because there's so many more angles, and we see that 1/2 is right here. And there's so many angles in between. So instead, we need to know how I can get rid of this sign and get theta by itself. And this is the process that we're going to learn today for inverse trig. One part about inverses is this. Inverse functions back in Unit 2. Inverse functions have this property where the inverse applied to its original function will give me x. Because f of x, f goes from x to y, for example. And its inverse goes from y to x. Because it swaps the domain and range. It swaps the x and y values. Therefore, going from doing f of x and then doing the inverse must give me x, because x is becoming y, and then y is now becoming x. So all in all, x is becoming x. the inside value, the input value, is the end result. We now apply this onto our trig function, where if I applied the inverse onto sine of theta, if I apply the inverse somehow, I must get theta. And the inverse of sine is actually just, you write sine and put the -1 power, just like the inverse. The inverse sine onto sine theta gives me theta. So applying this onto this problem before, sine theta equals 1/2. I apply inverse sine onto the left. What I do to my left, I must do to my right. The left side just becomes theta, and theta equals inverse sine of 1/2. You might think, what is this? Like, why? Like, what do I do from here? On your calculators, on every single scientific calculator, as well as graphing calculator, you should see a button. Usually, if you press second and look at the trig buttons, there's inverse sine. We call it inverse sine. It's also called arc sine in the future. But arc sine and inverse sine mean the same thing. If you click that and apply it, you see that we get theta equals 0.524. Let's also type in, like, that's one of our answers. We're not quite done yet. We skipped some steps, but at this point, we honestly, like, we got 0.524. Real quick, with your calculators, please type in sine of 0.524. You see that you should get very, very close to 1/2. But also, one more thing I want you to check is please do pi divided by 6. If you do pi divided by 6, you should see that you get 0.524. Alright, I'm going to try using this calculator a bit, but we'll see how it goes. So you see that inverse sine in radians of 0.5 gives me 0.52359. For the sake of this class, we will most often just round to the nearest thousandths, so 3 decimal places. And if I do this clear, 0.524, and sine of this, I see a 0.500, which is really close to 1/2. It's not exact because we did round, but we see that my answers do work. However, when we did it before, we see that we had 2 answers. There's 2 values. How do we get that second value? This is where we now need to build upon this and look at the quadrants. So I'm going to copy this table and use it to now talk more about tangent as well, because those are the 3 functions we have on our calculators. So we said before, sine of theta equals y, cosine of theta equals x, tangent of theta, tangent is actually opposite over adjacent. If the opposite is y, the adjacent is x, tangent of theta is equal to y over x. It is also equal to sine over cosine, but we will talk about this property more later. But we see that tangent of theta is y over x. Looking at our unit circle, we want to see where is y over x positive and where is y over x negative. In quadrant 1, we see that when I have like 2 positive numbers, when y is positive and x is positive, positive divided by positive is positive. So tangent is positive in quadrant 1. All trig values are positive in quadrant 1. You can also see a pattern here. If sine is positive at 2, cosine is positive at 4, 3 is not touched, so 3 is actually where tangent is positive. But let's prove that. At quadrant 3, we have negative and a negative. So negative y divided by negative x gives me positive y over x. The negatives cancel out. Whereas it's negative when you have 1. So at quadrant 2, positive y, negative x, that gives me negative. Negative y, positive x, that's negative. So this is something you can straight up memorize or look at your unit circle and keep track of this stuff. Remember how we derived it and how we found these conclusions. But these quadrants are useful in telling us where to look for our answer. In our first example, when sine theta is positive 1/2, I want to look at quadrant 1 and quadrant 2 for my answer. And our answers were there. At quadrant 1 and quadrant 2, we had positive 1/2. But now we want to find a way to do it without looking at unit circle every single time. And that is where these formulas come in, which you must know. In quadrant 1, my angle is found just by getting my angle. That's it. Because in quadrant 1, I'm starting from 0 and I'm going up pi over 6. Let's use pi over 6 as our example. I'm going from 0 and then I go up pi over 6. I go up 0.524 radians to get this angle. Looking at quadrant 2, how could I use this value? How could I use this pi over 6 to get 5 pi over 6, to get this value? I have two starting off points. I could either go from the x-axis or from the y-axis. If I add it up here, I'm not quite there. I make it to 2/3 pi, but I'm not fully there. Instead, what we could now do is go from pi and actually go backwards. Because we see that distance, that angle is the same. This angle right here is the same as this angle right here. For quartile 2, quadrant 2, our angle is not just theta, it's pi minus theta. For quadrant 3, let's keep on using 1/2 as our example. And we want to see where we find a similar coordinate value. So root 3 over 2 and 1/2. We see it right here. How do we get to this angle? I want to go down this much. We're always going from the horizontal. So I'm going down this much. So I'm adding it onto pi. Quadrant 3 is pi plus my angle. And finally, quadrant 4 is go from here down. So I'm actually going 2 pi minus theta. 2 pi minus theta. Let's now finish off our problem that we had before. I will make a copy of it so it's now in one place, where we found theta to be 0.524. When I look back at the original and see from this step, I have a positive 1/2, so I must have quadrant 1 and quadrant 2. At quadrant 1, I want just my angle, so theta equals 0.524. In quadrant 2, I want to have theta, pi minus theta, pi minus 0.524. That would give me, where is pi? Pi minus this value. How do I use it? .6. Yeah, that works. 2.618. I prefer not rounding until the very end, so I use the whole value. That is not necessary, but I think it is good practice for later. So pi minus 0.524 would give me 2.618. These problems will have many answers, so please rewrite your answers at one place. Theta equals 0.524 as well as 2.618. 0.524 is pi over 6. Pi divided by 6 gives me 0.524. And 5 pi divided by 6 is, that did not work, 5 times pi divided by 6, 2.618. Let's do one last problem. Adding one more twist when we have negative values. You see that we could have negative x and y values. Let's use tangent, let's use a negative, and make this a bit more complex. But this is kind of the whole process altogether and in a concise procedure. So tangent of theta is equal to negative 3. Actually, negative 3 is a clean number. This is negative 4. Actually, one moment. I kind of forgot about this. But when we have these values, like sine and cosine, sine theta equals y, or inverse sine of x, this function, this is not theta, but like is the value that we have. This would be a bit confusing, but if we had this and like we're not bringing the x inside, there's some clear rules that we have about this that we discuss. Theta, in order for this to work, we always find our answers from in between 0 and 2 pi for theta, because it is infinite. The graph does repeat forever and ever, and there's an infinite number of values where sine of that angle would give me 1/2. Because corresponding angles give me the same value, so adding 2 pi over and over will always work. So we limit it to just one period, one interval. One other thing that must be true is thinking about like, what are the max and min of sine theta? What does x have to be in between? My result, my domain in this case for my inverse trig functions, is it must be in between -1 and 1. One thing you can do real quick in your calculator is try doing, I'll say like positive 2. I want to do the inverse sine of positive 2, invalid input. Because sine can never be above 1 or below -1. We said on my unit circle, 1 is the max y value, -1 is the minimum y value. It can never be beyond that. That is the same for cosine. Cosine could only be max of 1, minimum of -1. Tangent, however, is different. Tangent can be every possible value. So for sine and cosine, this is true. For sine as well as cosine, this must be true. This restriction upon our values. So that when you do more problems like this, and you do see like, oh, sine theta equals 5, and you get a domain error, your calculator is yelling at you, don't be too confused. Understand like that can be true. That is your answer. Okay, now we could wrap it up with tangent, because tangent could be any possible values over here. Sine could only be from -1 to 1. Inclusive, tangent could be any value. So tangent, we now want to apply the inverse. So inverse theta, any way you want. So I actually like to swap my theta and my -4. Inverse tan of -4 equals theta. Step 1. Find quadrants. My quadrants for negative tangent will be quadrant 2 and quadrant 4. So I mark it down. I have quadrant 2 and quadrant 4. we can also add a text right here. 1. Find the get into proper form. The proper form in this case will be your inverse trig of your value equals theta. That's a bit confusing, but we can't really type in math in this way. Next up, we're gonna label quadrants. Mark it down somewhere. Quadrant 2 and quadrant 4. After that, if it's negative, you make the inside positive. Mathematically, we're able to do this because we labeled the quadrants first. We kept track of the quadrants before getting rid of the negative, because the negative restricts the quadrants. That's all it really changes. There are other methods that don't do this, but it is confusing in the other ways, like it is a trade-off between like one method and another. I find this to be the most practical, to be easy to keep track of, and it makes your answers much easier to follow. So let's actually apply this. I want to make the inside positive, so I do inverse tangent of positive 4 equals theta. We're allowed to do this. After this, we now plug into your calculator. Plug into calc. Inverse tangent of 4 gives you 1.326. This gives me theta equals 1.326. Now with 1.326, we found the value. Use that value on quadrants to find the angle in corresponding quadrants. And finally, we'll do this first. In quadrant 2, I have pi minus my angle. So in quadrant 2, I want to have pi minus theta, pi minus 1.326, to get a value of pi minus this value, 1.816. 1.816. Now we go on to quadrant 4. Quadrant 4 is 2 pi minus theta. 2 pi minus 1.326 gives me, let's clear it, 2 times pi minus my value, 4.957. 4.957. Finally, we rewrite our answers. Rewrite answers neatly. Theta is equal to 1.816 as well as 4.957. And that is a whole procedure. You are able to check, like what we did before, where we can now plug this data back into our original equation. That is a great thing about algebra, is that when you find your answer, if it is the correct answer and you plug it back in, you must get the same thing. So let's clear it out. If I do tangent, let's clear it out. 1.816, 1.816. Apply tangent to this, negative 3.99. It's pretty close. It's off by like 1,000, like a couple of thousands, which is fine. If it's off by like more than 100th and more than a 10th, that is where it gets a bit concerning. Like your answer is probably off. The next one, 4.957. 4.957. Tangent of this, negative 4.00. we say that we did get it. It is close and our answers are correct. To fully recap in this lesson, we talked about finding our values using the unit circle. We did this before in Unit 4. We are comfortable with the circle applying it, but now we want to look at angles beyond the unit circle that aren't clean pi fractions. And this comes with learning how to use the inverse of trig functions. We want to isolate it in a way to find theta. So we want to simplify as much as possible. So trig of my theta is equal to my value. We invert it, apply inverse. We label the quadrants of the inside. If it's negative, look at the negative. If it's positive, look at the positive. You make it positive no matter what. So a positive to a positive, that doesn't do anything. But negative to positive, that is what matters. We then plug into a calculator, use that value to find the values in the corresponding quadrants that we found earlier, and we write our answers neatly. If you have time at the last point, you can check it by plugging it back in and get really, really close to your answer. So that is 5.1.